So in the previous lecture, we had observed certain examples about random processes, and we had observed that for every outcome omega I in a sample space of sigma, there exists a signal of x of t omega I. Remember, in comparison to the random variable where we are getting corresponding to every outcome, there is a certain real number. But in case of random process, we are having a signal. So that is the difference. In random process, you are having a functional form of representation, whereas in the random variable, you are having certain outcome in terms of some real number. So in general, we can compare the random process with the random variable in such a fashion, that is, the random process is providing us a functional representation, whereas random variable is providing us a real number representation. So that is the major correlation between random process and random variable. We can very well correlate it again with this particular example, where I had shown you the general view of random process. So at any, let us say at some instant t, a functional form omega 1 had been observed corresponding to some random function. Again, at another time instant t to t, you get another functional form of representation. At another time t, you are having another functional form of representation, where omega 1, omega 2, omega 3 are possible outcomes of a function or corresponding to an experiment. So you can observe that there are different functional representation can be given at different time scale or at different observation level. So whenever you are repeating certain experiment, whatever functional representation you are observing, that may be different from the previous one. So that is the basis of random process. So we can say that for each omega I, there exists a deterministic function xt of omega I, which is termed as a sample function or realization of the random process. For example, let us say we are always aware that there is a resistance in our lab. Whenever we take a resistance and try to find out its resistive value corresponding to with the help of certain multimeter, we observe that the outcome is not a constant one. For example, it's a 10 kilo ohm resistance. We will not get an exact 10 kilo ohm value at every time, but we will get a certain fluctuating value. So what are these fluctuating values? So if we plot this fluctuating value with respect to time, we will get the same resistance is providing me different value at different time. So that is representing a sample function or realization of that particular random process, which we can term as a resistance value or observed across the resistance. So at each time instant t0 and for each omega I, which is belonging to the sample space, we have the number xt0 omega I. So if I fix an instant t0, that is particular time instant t, if we try to find out what corresponding to each omega I, what is the representation level, so we will get a set of number, and for different outcome at a fixed time instant d0, there will be a set of numbers which we can obtain, and this constitute a random variable which is denoted by xt0, which we can show it here over here. Again, functional form of form of signals are given over there, but at instant t0 I am taking the value of each signal. So at t0, this xt omega 1 is having certain value over here. At xt omega 2, which is again I am measuring at t0, it is having some value over here, and xt omega 3, I am again at t0 I am checking this value, it is showing some value over here. So what we will observe? We will observe a set of numbers which is corresponding to this t0. So that will give me a set of random variable. So you can say that a set of random variable is nothing but when you are observing a set of random processes at a particular time instant t, you will get a random variable. So we can simply conclude it by at any time instant, the value of a random process is a random variable. So at any fixed time instant, the value of a random process is a random variable, as it is clear from this figure. That is, all these random processes are there, but I fix the time instant t0 where I am measuring the value of all functions over there. So that gives me a set of real numbers, that is nothing but the random variable. So this is the correlation between random process and random variable. I hope it has been clear to you and you are having better understanding about the random process and the random variable. I had covered this topic with the help of book of by Janji Prokis and Masood Salahi from Pearson publication. Name of the book is Fundamental of Communication System. Thank you.